We all know things behave differently in microgravity, but knowing exactly how materials behave is vital to future spaceflight, and it's already helping improve products here on Earth. Let's head out now to the Payload Operations Integration Center at the Marshall Space Flight Center, where Lori Meggs is, to tell us more about materials research. Lori?
The MISSE, or Materials on the International Space Station experiment, has been studying the way materials behave in the harsh microgravity environment since 2001, and much has been learned. I recently spoke with one of its principal investigators, Kim DeGrove from the Glenn Research Center, to learn more.
MISSE is the Materials International Space Station experiment, and it's a series of materials experiments that are flown on the outside of space station, so we can study the durability of materials and devices in the space environment.
What number are we on now?
Well, MISSE 8 is actually, it's the 10th of a suitcase-sized tray that was flown, and it was up in space for 2 years, and it was recently returned during the SpaceX 3 mission and returned to Earth in the Dragon capsule.
So we've done this for so many years. What are some of the highlights and key points that we've learned of how materials behave in space?
The MISSE experiments have provided a very wide variety of information on the environmental degradation of materials in the space environment, and also on devices and how they perform in the very harsh space environment. And every mission we have flown different types of experiments with different kinds of samples, and we learn different things each time. And we're also finding now that sometimes we'll refly the same material on different missions. They get different environmental exposures, and we see that the degradation rate of some of these materials is not constant over time in the space environment. So actually flying the same sample again and again is very helpful, because you may see that the degradation is getting worse over time, or is not as bad over a long time as you might initially think.
Is 2 years an optimal amount of time to have it there and see how it's going to behave?
2 years is a good amount of time to have a space exposure experiment. 1 year you can learn a lot still from 1 year. It depends a lot on the experiment and what you're trying to find out about it. But having an experiment up for 1 to 2 years is a good amount of time, because it's long enough to see the degradation, but it's not so long that you have to wait a really long time to get your data and know what's happening.
Can you tell us about some of the things, some of the materials that we've learned, how they behave, how they've been used now in spacecraft and other things?
Yeah, there have been a lot of different materials that we've learned about the degradation and durability, and we have had MISSE data that have impacted a whole variety of different spacecraft programs, everything from Earth observing satellites, communication satellites, lunar spacecraft. Our MISSE data even impacted one of the Mars rovers, and we've impacted material selection for the James Webb Space Telescope and some other telescopes. So the MISSE data has impacted a really wide variety of spacecraft. There are a lot of different Earth applications from the MISSE flight data. For example, we learn about the UV radiation durability of materials, and we know down on Earth the sunlight comes down and can damage materials. We also learn about more efficient and durable solar cells, and we can use that technology for building more durable solar cells here on Earth also. So there are a lot of different applications from the MISSE experiments that we can use down here on Earth. In the entire MISSE program, where we've had 10 different suitcases, we have had hundreds of principal investigators flying samples on these packs from 85 different organizations. We have investigators from NASA, Department of Defense, academia, and industry. So many, many different participants in the MISSE program, which is really wonderful and very unique too.
And as Kim mentioned, hundreds of scientists and engineers have had experiments on MISSE, and joining me now is one of them, our principal investigator from here at Marshall, Miria Finkenauer. Miria, thanks for joining us. Tell us about your involvement with MISSE.
Well, MISSE has flown over almost 4,000 materials samples since 2001. And some of those are pure research, like from Langley and from Glenn, but the ones here from Marshall are ones directly applicable to spacecraft, especially space station itself. As we look at life extension for space station, we look at the radiator materials, the window materials, the space debris shielding, and we look not only to see how those are holding up in the space environment, but also how well we simulate the space environment on the ground. That if we do tests on the ground with new materials, how well are we replicating that?
Tell us specifically about what you've been studying.
Okay, this is the trailing umbilical system cable, and this was flown for 4 years on Missy 2. So we looked at how well that held up, and we want to make sure that the astronauts are safe when they're out on EVA. And one of the nicer points we had last year was with Don Pettit when the Dragon came in to dock. He made a comment about the snow white coating on the Dragon, and that was actually a coating that we qualified on Missy 2 for that mission. So
yeah,
it's good to make sure that what we're doing actually helps the astronauts, as well as keep the space station operating smoothly.
Tell us about some other things you've looked at.
Well, this is Nomex. This is one of the materials that was used in the tool bags, and we know now that we need coatings for that.
Yeah, that didn't
hold up very well.
Wow, that's very interesting. So how long was that on station?
That was 4 years.
4 years. Wow.
And then we're also looking at some of the new programs, especially supporting Orion and the Multipurpose Crew Vehicle, James Webb Telescope, the missions to Mars and to lunar environment, some of the other missions to L1 and L2.
And you were also involved in Missy 8, the last one that she talked about. It just came back,
yes,
a few months ago, and I bet you're anxious to get your hands on that.
Yes, I am.
All right, when will you do that?
This week, after I leave here.
Oh, we might go visit with her.
Okay.
Marian, thanks so much for joining us today.
Thanks for having me.